At the exact moment a star dies, its core collapses faster than the speed of sound, releasing more energy in seconds than our sun will emit over its entire lifetime. This single event can forge the heaviest elements in the universe, trigger gravitational waves, and determine whether a black hole or a neutron star is born. The long build-up before death. A star does not die suddenly. For millions to billions of years, it survives by maintaining a balance between two opposing forces, gravity pulling inward and nuclear fusion pushing outward. In its core, hydrogen atoms fuse into helium, releasing energy that keeps the star stable. As fuel runs out, this balance weakens. Smaller stars, like our sun, die quietly. Massive stars, at least 8 times heavier than the sun, die violently. The exact moment of death depends entirely on the star's mass. The exact moment, core fusion stops. The precise moment a star dies is when nuclear fusion in the core stops permanently. For massive stars, fusion progresses through heavier elements, helium to carbon, carbon to oxygen, oxygen to silicon, until iron forms in the core. Iron fusion does not release energy, it consumes it. At this instant, the star loses its ability to resist gravity. This is the true point of death. Core collapse, a fraction of a second. Once iron builds up, gravity takes over. The core collapses inward at nearly 70,000 kilometers per second. Protons and electrons are crushed together to form neutrons, releasing a flood of neutrinos. This collapse happens in less than 1 second. The star's core shrinks from the size of Earth to a sphere only about 20 kilometers wide. Matter becomes so dense that a teaspoon would weigh billions of tons. The explosion. Supernova ignition. When the collapsing core reaches nuclear density, it suddenly stops and rebounds. This rebound sends a shockwave outward. Combined with the intense neutrino burst, the shockwave tears the star apart in a supernova explosion. In these seconds, temperatures exceed 100 billion degrees. Heavy elements like gold, platinum, and uranium are formed. The explosion briefly outshines entire galaxies. This is not just destruction, it is creation on a cosmic scale. What forms after the star dies? What remains depends on the mass of the core. Neutron star. If the core is between about 1.4 and 3 solar masses, it stabilizes as a neutron star, an object spinning hundreds of times per second with magnetic fields trillions of times stronger than Earth's. Black hole. If the core is more massive, gravity overwhelms everything. Collapse continues endlessly, forming a black hole. Space and time themselves warp, and an event horizon forms, the final boundary beyond which nothing escapes. At this point, the star is truly gone. For smaller stars, a quieter death. Stars like the sun never explode. When fusion ends, the outer layers drift away, forming a planetary nebula. The core becomes a white dwarf, slowly cooling over trillions of years. The moment of death here is still the end of fusion, but without violence. Why this moment matters. Every atom of calcium in your bones, iron in your blood, and gold in electronics was forged in dying stars. The exact moment a star dies determines the chemical evolution of galaxies and the conditions for planets, and life, to exist. Stellar death is not an ending. It is a transformation that shapes the universe itself. If you want to understand how cosmic events billions of light years away shape everything we are made of, subscribe for more science-driven explanations of the universe, where physics meets reality, not speculation.